Okay, the connection is broken. Now we're live again. So no online viewers at the moment. Okay, we picked up a couple of viewers here after we dropped everybody. Sorry about that. Thank you for your patience. We're back. So we're going to check up on how it's going for Chip and David right now. Oh. Is this fully built or taped down? Wow. David, can you tell me this is taped?
Yes, that's taped.
Okay. So here's a working model of a complete beat P2D2 that David put together with double-sided tape. So what he does, it takes a while, but the results are always worth it. But it's definitely appropriate. We have 2 tracks going on this right now. So this is a bare PCB with double-sided tape and all the parts properly placed. And he makes this board to help him with the setup and parts placement. The YouTubers say, go get him. Go, David, go. Although this one has no hole in the back, just a very little one. But what Chip has been doing is drilling that out, and he's hand soldering a chip to a board, a P2, which has a hole to access the ground plane on the back of the chip, so all grounds can be tied together. So sure appreciate your patience today. It's 5:30 p.m. here on the West Coast. The Propeller 2 package arrived this morning at 10:30 via FedEx. And at 10:45, Chip was here. And he's been working nonstop, trying to get one to program. We're fairly well prepared with this board from Peter, too. This helps. And look at the laser etching on that. Chip, were you able to get the solder to stick to the back of the chip?
No, it's weird. I think that those packages that they used were old and they were
Oxidized?
or something.
Is that a necessary ground to connect?
Yeah. Oh yeah, it's the only ground.
So how are you going to do it? Just run a wire against it or what?
No, I just kind of did as well as I could.
More flux?
Yeah.
More cowbell?
Yeah. That's what I did. All I could do.
So yep, he's doused it in flux, I'm sure. And right now, what are you doing?
Putting the last wire on.
Okay, so we almost have another set up. More cowbell. Hopefully we don't have to take this board to visit the manual milling machine. The last one suffered an unfortunate destiny. Dogs around the world are forbidden from going pee until Propeller 2 runs. People are probably getting hungry watching this. You guys got any commentary for this? David just told me to shut the heck up. He doesn't get angry. I'm just complaining, Jeff. Okay, Chip took the board over to wash it with the deionized water. And he's going to spray some air on it. And he's going to come back over here to this programming station. And we are going to program it. So I'll give you another look at this if you just joined. Sorry, unfortunately, we dropped half of our crew because I did what Roy told me not to do, which was walked around the office with a computer in my hand. Roy knows best. Roy knows that I'm a slow learner. Yep, you got something ready to go? Oh my gosh. Okay, here. Okay, wait, two exciting things are about to happen. Which one do you want to see first? Okay, let's see what David's got. Pressed. And pressed again. He's doing some trickery to get this machine to do what he wants. Like putting in a plastic key so the safety override doesn't trigger with the door open. There's always something with this. Meanwhile, the heat just continues to get higher and higher in here. If it gets so hot, I might reflow my Surface computer. Oh, things are moving. Pushing things out of the way, placing a circuit board. Attempt to grabbing parts. Oh, there, a board just fed. I don't know if you saw that. David's encountering a few errors, but maybe
One of the parts, the most common part we ever use is not coming out of the reel.
Oh, the reel's sucking on the parts? So the problem from all of this is that a reel's holding parts captive. And this is not a dry run. This is the real deal. Ooh, and then it came out the other side. Now it's in the inspection station. Okay, we'll let David get a good look at it. He knows what to look for. Thanks, David. How awesome was that? Meanwhile, in other corners, Chip seems to have relocated himself.
All right, now we're ready to, we have another chip on a board like we did.
Okay.
Here's the 1.8 volts.
Hang on, people want to get positioned right. They're lining up.
Here's a 3.3 volts.
Viewer counts are just going through the roof.
And
Current limiting.
Yes.
Yes.
All right, now.
Easy.
So let's just review. We got 1.8 to 100 milliamps, 3.3 to 100 milliamps. Turn it on. Okay. All right. No discernible current flowing, which is maybe good. And let's see now.
Bringing the computer back up. So chip's board only has a P2 on it, and the resistors for the prop plug, right? And then a
Right.
header for prop plug. That's
Right.
it.
Now let's see here. Let's get this thing. Just tell it to keep going. Auto. Where's this? Is this it? Oh, what a mess.
We don't have any champagne here.
Yeah. And we should probably just have some ramen soup.
We are getting kind of Donner Party hungry, aren't we?
All right. That.
The Cheetos sound good. Okay, fire up the scope, see if this
Okay,
works
now
for you
let's
guys.
see.
So chip is currently probing what pin, Chip?
This is reset. Should have a pull up. Should be able to pull it down like this. Yep.
I'm just going to turn that to get rid of some glare, okay?
Now, let's hook a prop plug onto this. And it goes like this. All right, now.
Is the prop plug connected the right way?
Yes. Okay. Okay, no hardware found. Let's see if we see a reset pulse coming in.
Now we're looking for the reset pulse. So we had a no hardware found.
Single.
And Chip just attempted
Okay, there, that's the reset pulse.
A little spike down.
Now let's check for. Now we're going to try to do a download. Hold on. Wait a minute. Let's look at the reset again.
Still monitoring the reset line. Download attempt.
Oh, wait. Oh, it already captured. Let's do it again. What is this thing doing?
Meanwhile,
Okay.
Carrier is about to send one through a reflow oven too.
Gosh, it keeps triggering. Okay, there. So there's our reset pulse. There's our serial from the PC. And then what we're not getting
Is a
would come
response.
here is a response.
Still having a one-way conversation, right?
Yeah, it's just not responsive. So, okay, if I take the prop plug out, let's see. Let me just check some things here. Here, 1.8 volts here. It's like our power supplies.
Chip, are there caps on the power supply?
No, that shouldn't matter. Anyway.
Okay, because of the external power supply.
Yeah. So I'm kind of getting the same behavior as I did out of the last one.
So things look similar to the prior version.
So might.
Have we tried reversing the transmit receive on the prop plug? On more than one occasion, I've gotten that wrong way around when designing a PCB.
All right. Well, we can do that. Hey, okay. What we need are some of those wire things. You know, posts on one side and females on the other.
Yeah, male, female.
Yeah.
Okay. All right, Redverse. Okay, we got one coming off. So, David, I got to give some male, female jumpers for Chip. Then I'll come back and grab a look at that. So we're going to check the TXRX switcheroo, male, female, right?
Yeah. I can determine actually. Let's see. My buzzer. We measure the. Let's see. This one should be the first one. Yeah, it looks maybe unlikely that we have any signals backwards. Like it's buzzing out okay. Unless, let's see. Reset TX RX. Yeah. We'll try it out.
Okay, this would be for red.
Got 4 of them?
Yeah. What colors you want?
Just all the same color stuff.
Okay. As requested by red, TXRX switch.
All right. There's ground.
Prop stuff. I think we did check the signals at the chip. Oh, we didn't check them at the chip, but at the edge of the prop plug. Chip, would it be useful to check the serial signals at the chip I/O pins?
Yeah.
Yeah, we'll do that too.
Yeah.
That's coming, prop stuff. Keep sharing your suggestions. They're all welcome.
Yeah. All right.
Yeah, these wires are similar to that. Okay, so let's get a little closer look here.
Okay, so if we want to reverse to, we can pull these out and switch that. Yeah, no difference. Oh, wait a minute.
You sure you have that right, Chip?
Yeah, this looks right.
We're going to give it one more try, Red.
All right. Now, let's see. Where's the scope? Oh, here it is.
Now you're checking the signals at the prop chip, the serial.
Let's check the reset.
Okay, so now we're going to check the reset on the.
Can you hit that single sequence, that button?
Which one is it?
Single SEQ.
I'm looking.
The upper right.
Yeah, ready?
Yep. Okay, so that's the reset. That looks appropriate. Now the next signal is going to be the serial message. You ready?
Yep.
Did you hit it?
Yep. Oh, there's your serial data.
Okay, let's.
And that's at the chip, right?
Yep.
Okay, so.
But that doesn't look right. Let's try it again.
Oh, it's all noisy, right?
It might be because of our time.
Tell me when to press the button.
Okay, hit it.
Single sequence
Okay,
capture.
now it's good.
Okay, that looks
so
better.
That's what I would expect.
Ooh, David just showed up with something really cool. Look at that beautiful board. Yeah, Jeff, we'll try to. I'll fix that glare next time.
Where we need
Yeah,
it.
I brought 2 of them over.
Okay, well, I used 2 of them on this one. All right, so I'm going to solder this like
Peanut baud rate, is it fixed?
What's that?
Peanut's baud rate.
Yeah, it should be. I mean, it should be.
And it would match
We
the,
should see.
do you want me to check in your COM port settings or?
No, it can't. It's
Okay.
set. Hey, Roy.
Oh, the fan club.
Roy,
Yeah, David, that looks awesome.
are you there? Roy.
So Chip's getting more calls. Okay, yeah, we will do that, Lachlan. We'll switch power supplies over to the X-Stack. I like that little power supply. It's worked well. Chip, Lachlan suggests we use the X-Stack power supply next time, just because it shows lower current.
Yeah, I know. We're not seeing that.
Yeah, we'll switch over to that one. And we'll check the baud rate. So we got baud rate, power supply, and prop step. There's always a good chance things are rotated.
Okay.
Either within the package, possibly, what is there, a 1 in 4 times a 1 in 4 chance that if we just guess, we get it right? But we have good knowledge from On, who of course does this every day, that pin 1 is where pin 1 is, and the schematic is quite clear looking at the PC board. I think we got that right, but I could tell you in the past, when we've done serial D9s, half the time we've gotten them wrong. And so we really learned how to get them right, because it could be at the diagram from inside the shell or really inside the cable, which is versed. So it's a great question. That message to go away. That's bad. That red X there. So, oh, Roy's on the phone. That go away.
In my app, it's like.
So we're going to check that. Roy's on the phone with Chip right now.
No. No, because it uses the internal oscillator now runs it. It'll never run less than 20 megahertz. So it should. Well, it should be okay.
We'll try all these suggestions, you guys. Okay, so Jeff, keep track of these. So we have check the baud rate. We want to switch out the power supplies. And we want to see if there are any running signs of life that are normally there when power up. What do you?
So punch drunk. I'm not even thinking straight. Okay. All right. Right. Okay, yeah, good idea. You're right. We should just be able to have the old conversation with it. Okay.
Was pushing data through here at a super high speed.
What should I get? I need to download a terminal program.
Use PST, Parallax Serial Terminal. It's the best one available.
I don't think it's on my machine, though.
Just go grab it. Just type in PST. You don't even have to. You could download it alone.
Well, and I might even have it here. I think I have it here. Hold on. Let's see.
Parallax Serial Terminal is a standalone, beautiful piece of software from Jeff.
Let's see.
It has transmit, receive, everything we've ever wanted in it is there. Character positioning, transmit, receive panes.
If I go to run, maybe I put the propeller stuff on this.
This Windows stuff. Just type in the search bar, Serial Terminal.
Oh, let me type in propeller tool. Propeller tool, here we go. All right, I'm getting in there, yeah.
The idea here is
it didn't occur to me, Roy.
To use PST to
Yeah. I forgot that it was supposed to be easy. Okay, propeller.
What's up, Red
let's see
Verse?
here.
What's your
Run
Radanom question?
Parallax serial terminal. Okay, and we are COM3, 115.2. And let's see. How do we get into this thing? Like, right. Oh yeah, I can.
And then you have to type prop whatever your command to prop CHK 000.
I know, but to get into like the tool, remember what was it? To get into those guys' tools.
Oh, I don't remember.
Lachlan says
just-
F12.
Maybe you can just hit enter a bunch of times or something.
Because that determines the boot mode.
Or space or something. I don't remember.
All right, let me go to prop. Let's see.
Hey, David. On your board, what pull-ups, pull-downs got loaded?
All right, let me do the thing where I just download a program to it.
Okay. Okay, we'll go over there and take a look. Lachlan?
Okay, all right. Okay, thanks a lot. Bye-bye.
So R1 and R2 were not loaded. And then pull-up resistors, R4 and 33 were loaded.
R4 and 33, and the values of those?
Those are 10K.
10Ks. So we're trying to talk to the chip via terminal.
Right. Yeah, I don't think it's not really being responsive here. Let's see. He says everything's on the board and on the prop plug.
I can grab you a prop plug that has 3 sets in it.
Well, okay. This P2D2 has some kind of reset buffer. But it looks to me like it's inverting.
Yeah.
A couple things going on here. We have the support of the Germans. Excellent. They're online. They're up late tonight, too. It'd be about 2 a.m. in Germany.
Let's see.
Code developer, wie viel Uhr ist
Is
das?
Peter or Clouseau on there?
Peter is gone missing. Clouseau is not here. We have Lachlan and we have Ozprop Dev. So we have 2 out of the 4 Aussie contingencies. Jeff wants to know if you jumpered around the reset buffer on this new board.
Well,
He's still programming the one that David did not build, the one he built. The P2D2 reset is just the usual prop plug circuit, but with 220 ohm serial output on reset.
say what?
The P2D2 reset is the usual prop plug reset circuit, but with 220 ohm on serial output on reset.
I'm not getting any. Yeah, I should be able to say pop check.
So Chip's looking at is top that allows communication over term. Roy's idea. And I see the prop plug lighting up.
Yeah, we're not getting any response.
Do you have like double prop plug circuits here?
Well,
Would that be an issue?
no, there might be on the other board.
But this one has, David's bringing us something else.
Okay, hey, well, where do we put the power in this stuff? Well, I just made my own setup. Let's see.
Looks like David thinks that we should now try his pick and place assembled board.
Lower right corner.
Check.
Chip, questions on here about the prop plug and reset circuitry.
Oh, wait a minute. This is a USB to SEER. This is something different.
It's a prop plug with the transistor and with the serial line runs straight through.
Yeah, but it has a different pinout. Yeah. Yeah, this was an old thing. Where'd you get this?
I got. We can.
Yeah, we should be able. The lower right pin is left.
Chip, comments. Let me read current draw. Switch over to the X type.
So what we'll do is
Turn that bad boy off.
No, just like this. That's all I gotta
That's
do.
right.
So we're gonna put, I need the both power supplies.
These both?
Yeah,
This is a problem.
yeah, because I have to have this one. This is only one output. So I'm gonna use this.
I have to find you the power cable, okay?
Hopefully this guy's amp.
All right. This might take a few minutes.
Can you just pull one off with something else here?
Well, they can't see what's going on. I gotta jostle around a little bit. It's okay. Okay. Let's see what's happening. So put this guy in. So we can go find a cord. So I'm gonna head back to the
Pull
junk
one off that
pile.
thing right there. We're not using that.
Well, I don't want to unplug their equipment.
No, we'll plug it back in later. See
Okay.
that echo thing?
Yeah.
Pull it off of that. There you go. Now plug that into this. All right. Yeah, this shows milliamps. Okay, so,
All right.
so for volts, we're gonna
What do you mean the
say-
video hung again? Looks fine to me. Maybe if we get more pissed off, this will work. Please. Maybe this will help. So where we are now is we currently have in front of us two built-up P2D2 boards. Actually, the first one was built by Chip. This is really the second version built by Chip. And we drilled out the bottom of the board to make Chip. Before that, a plug connector was needed for the program. And then the second board David handed us came off the pick and place. It's fully built. And we'll probably try that board in a minute here.
And this thing is like.
Okay, let's see. I've used this one
Oh,
before.
upper
You have top
voltage
foot on it.
Okay, there's the, the upper voltage limit. That's the upper voltage level. Here's the voltage level. So we want to review. We want the voltage to this.
I think you have to turn the output on for your.
Well, we want this.
Yeah. It's nice in the power supply, isn't it?
8 volts.
Okay, we got that set at 1.8. And how's the video working for everybody? So Chip, Michael Marzek says, verify the reset circuit. It's always held low per the schematic. Jeremy?
Verify the reset circuit, yes. Just a second. This power supply. Okay, here we go.
This one, the 1.8 one where you guys working with the 1.5.
So this thing thinks. Okay, so now 5 milliamps.
Thank you, Lachlan. It's a good suggestion.
Okay, I'm gonna reset this thing. In fact, let's just pull this off for now.
Okay, so we have your assembled board, right? Chip? Okay.
All right, so reset this guy. So now we see 7 milliamps. I'm gonna hold it and reset, let go. No difference. I think this would be showing some difference. Unless, problem is that we're really hung up.
Chip? A comment, the board circuit is holding it low.
Okay. All I have on here is a pull-up. So if we look on here at the reset signal right up here.
Yeah, but yeah, there's no circuitry on this board for that.
Wait a minute, why is it so low? Oh, I'm gonna turn this off. Oh, now it's 75.
I think that one, the power supply is still on, Chip.
Yeah, no, this is, okay, this one. Okay. Let's reset this. So here's the funny thing. Okay, there.
There it goes. That's
Okay, I'm
low.
holding it in reset. It's very low. Let it off reset. Oh, it stays low. You know,
It should pop right back up, right?
you should start running the program. So let's see. I'm thinking, what if we have a problem where we're this guy 0.3 volts.
David showing up with
It'll regulate the 1.8.
fully assembled
All right.
with power supply on board, David?
Yeah, well, there's 2 power supplies, but it looks like only one of them is working.
Okay. Which one's working? The
1.8.
the 1.8. So he has a fully assembled board with 2 power supplies. The 1.8 power supply works. So I guess we'd provide the other power from a benchtop.
No, this is just so weird. Wait, let me. Okay. So that we're seeing that the reset pin has 3.3 volts. If I short it to ground. One thing is there's like no change in current. What if I take and pull up? If the chip was bonded backwards, I were to pull up one of these pads. Huh. All right, so what was, Lachlan had said something. What did he say?
Okay, Lachlan, what were your suggestions? They've gone quiet. Should we try just for fun something totally different? Go to David's board?
Well, we could. All right, so David, we'll try your board. Your board is here. Okay, so you've got this. What goes where?
3.3 volts.
3.3 volts?
Yeah, I think it'll regulate.
Does it, oh, but it doesn't have a 3.3 volt regulator?
It does, but it's coming out at 4.5. Or 1 volt. At 1 volt, I think.
Some discussion about the
So should we really
3.3 volt regulator, which isn't working
Well, we
right.
put a 3.3 here. And then
right.
then it'll backfeed and then run this one at 1.8.
What won't that be?
No, I'm fine.
Backfeed
I'm
to
just,
the
we're just watching.
You're saying this
Thank
guy
you.
will connect
They're
this way.
configuring They're configuring Raspberry Pis right now in
It
Elizabeth.
takes how long?
Yeah, I've been online through her
How does
Parallax,
that
speaking
Uh,
through one of her
you're
robots.
saying that's
while
gonna act
they're
as a
doing this
diode?
right. So far, so good.
Going that way?
Yeah, that's
Oh,
kind of
nice.
Trying to get the
right.
Pi configured.
Nice.
So I think it's gonna go all right.
Well, it was hitting 1.8 on here.
We're still
I put
messing around trying to get a chip to talk to. Peanut.
All right, so here's what we're gonna do. We're gonna take this to
But
3.3.
right now we have David's board off the pick and
All right,
place.
so this is gonna
This
go
is something
here.
new. So let's see what that
This
does.
is gonna go.
I'm not done with it.
You are?
Like
Okay,
this.
getting sick. Okay, thank you.
This
Wait,
circuit,
red. That's round, isn't it?
yeah, black and brown.
Is black
Just sit
round?
tight,
Yeah,
guys.
we're
We'll come back to your questions here.
Oh, okay, it'd be here.
Right now, we're hooking up the pick and place built board
Then also,
All right, then this is gonna go here. Here we go. Let's see how much current it takes.
and doing a current
Took
check
just a
on
little bit of current.
it. Takes 3
and then
milliamps
this
of
one
current.
right here is double because I'm also on the top.
All right. Yeah, it's gonna be inverting.
Yeah. So it'll work twice instead of once.
It'll invert one and just mess things up.
But if you use that USB to serious fucking things around, then that one I bypassed.
Okay, well this. All right, let's take a look here. Let's see. Here. 1.8. Wait, David. All of the voltages are 1.8. There is no 3.0. Wait, there's a 3.3. This should be 3.3. Oh, you know why? Okay. This guy has split 3.3 volts supplies.
Yeah, I plugged in.
You plugged into the other one.
And this part isn't there. So the 3.3 VC doesn't
Okay.
connect to anything.
All right, what we need to do then is we need to take.
Oh wait, but that's what this is.
We need to connect this. Look, we need a wire that goes from here to here.
From UV to you can see.
Yeah.
Okay.
Sure. You got that? Yeah. Okay. Oh my goodness, this thing, it's just not making sense. It's like I'm not seeing a single sign of life out of this thing. other suggestions on the
Okay, so suggestions here, questions about the reset circuitry. A common question that keeps coming up, are there any signs of life that the P2 would give on any I/O pins just from powered up?
If there's a pull-up on P59, yes. I have a pull-up here that we can put on P59. So let's see, go from here. All right, now. Where's our ground? Okay. Oh, now somehow we're taking 77 milliamps.
Hmm.
Let's see if that goes down a bit, like in 1 minute. Or I should just give it a reset. I don't know if it's ever properly reset. Let's see if I reset it. Okay, good.
It went down and came back, didn't it?
Yeah, if I hold it in reset, it's really low. I let off. Okay, good. That might mean it's running. So it would take about 90 seconds for it to time out. Or no, maybe about 75 seconds.
And then what would you expect with current draw?
It should drop to really low, like 2 or 3 amps.
Oh. After 90 seconds? Okay, so prop stuff, this is for you.
75.
So after reset, chip expects timeout a minute and a half later, and then current draw should go really low.